Hi, this is Miss Claywell here with Skill 19 Notes, Graphing Compound Inequalities. So far we've done inequalities that just only have one constraint. So like the arrow just goes one direction or it is stuck in between. It just only has one constraint. So for example, the first one, Example 1, write an equation of an inequality that represents a following situation. If you get 4 or more logs, you receive a detention. So x has to be greater than or equal to 4. So the only constraint is it's greater than or equal to 4. So if I were to graph this, here's 4. I have anything 4 or above. My example 2 says write and graph an inequality to represent the following situations. You can only attend Heron if you are in between grades 9 to 12. So I have 2 constraints. So my x has to be in between 9 and 12. I can be in 9th grade, so it's greater than or equal to, or less than or equal to x. 9 is less than or equal to x, and x is less than or equal to 12. So then when I graph this, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have to stay in between 9 and 12, so I have 2 constraints here. That makes it a compound inequality. So example 1 is not a compound inequality. Example 2 is a compound inequality. So this is saying write an equation that represents the following situation. You can have your phone out at school before 9 a.m. or after 4 p.m. So as an equation, x is less than 9 a.m. Or greater than 4 p.m. This is a little weird to do because of time. On a number line, I'd have 9 a.m. and 4 p.m. I can't have it out at 9 because it should be away when class starts. But I can use before 9. So now we're going to talk about write an and inequality statement, or an or inequality statement. In example 1, we had an or. So write and graph all real numbers that are greater than 2, or greater than negative 2, and less than or equal to 6. So we've kind of already done this a little bit. Are greater than negative 2, or less than or equal to 6. So I can include 6, I can't include 2, and I can include everything in between. That are less than 0 or greater or equal to 5. So on my number line, I'd have 0, 5, less than 0, greater than 5. So usually this or, I'm going to need 2 equations. Here, these are similar to what you've seen before. My goal is still to get x by itself, but I just have to remember, so I know I need to add 8, but I have to think about, do I add 8 to one side, to both sides? I'm going to add 8 to every portion of this, the right, left, and center. Then when I divide by 3, I need to divide the right, left, and center by 3. 2 is less than or equal to x is less than or equal to 6. 2 and 6. So I can include 2, I can include 6, and I can include everything in between. This is an or, which means I'm going to have 2 statements, and meaning their errors are most likely going to go opposite directions. So I'm just going to solve one at a time. 3 is x is less than or equal to 3, which just means x is less than 1. I made a mistake. I did not copy it down correctly. I should not have flipped that, so that's my mistake. So x is less than 1 or greater than 6. So when there's an or, these are going opposite directions. And once again, these are all considered compound inequalities because I have more than one constraint. Going to add 2 to each side. 0 is less than negative x is less than 3. I want to divide everything by -1, and we have to remember when I divide by a negative number, I have to switch my inequality. So I have -3, I have 0, x, 0 is greater than x, and x is greater than -3. So I'm going to be in between -3 and 0. Example 6, I have the same concept. I want to do my operation to every side. Going to divide everything by 2. So -4 is less than x, and x is less than 2. I have an open and a closed circle, and I can have any of that area in between. So here's an or. I'm going to treat them separate and solve them separately. I have a times a 2, a times a 2. Negative x is greater than 4. X is less than 4. Here I want to get rid of the denominator of a 3, so I'm going to multiply everything by a 3. And I made a mistake here. This should be a -4. So x is less than -4, or x is greater than +6. Here, I see that I have my fraction, but I want to subtract my 2x from both sides first. Then I can multiply everything by a 3 times 3 times 3. -12 is less than x is less than -3. So my x value can be anything between negative 12 and 3. The sum of 4 times a number and 8 is between 0 and 12. So I know my bookends are 0 and 12. 4 times the number and 8. I'm going to solve this. Okay, I just rewrote that higher, you guys. Then I'm going to divide both sides by 4. And the way to explain this is we know that x is in between negative 2 Oh, I made a mistake. I just processed this. 12 minus 8 is 4. So x is in between negative 2 and 1. 1/2 of a number increased by 3 is greater than 0 or less than and equal to negative 3. So my mistake in that is when there's an or, we write it as 2 equations. I'm going to rewrite this really fast. So 1/2 of a number increased by 3 is greater than 0, or 1/2 of a number increased by 3 is less than or equal to negative 3. So I'm going to subtract 3 from both sides, multiply both sides by 2. X is greater than negative 6. Or, we'll see what I get for the other side. So x is greater than negative 6, or x is less than negative 12. You need to buy notebooks at the bookstore, which costs $4 a piece. You know that you need at least $31, but your parents won't give you more than $51. In addition, you must pay $3 to park in a parking garage. Write and solve a compound inequality to determine the highest and lowest numbers of books you can buy. So I'm in between $31 and $51. I know each notebook is $4, and then I have to pay $3 for the parking garage fee. So I'm trying to solve for the range of how many notebooks I could buy. So I can get 7 to 12 notebooks. So this is skill 19. Be ready to ask questions in class.